Howdy, my name is Kelly Brumbelow. I am a faculty member and the associate head of the Department of Multidisciplinary Engineering. Welcome to Department Information Saturday here in fall of 2024. Normally we don't do a video here in this session, but unfortunately when the date for the event was set, the three of us who take turns giving this presentation in person had all made travel plans to be out of town today, and so we're doing the best we can. We're going to give you about a 20-minute video to introduce you to the interdisciplinary engineering major and degree, and then we'll turn it over to those folks who are there in the room with you, which includes our fantastic ITDE students. They'll introduce themselves, tell you about their experiences in the program, and then answer any questions that you might have. So thanks for being here. I apologize that I can't be there in person with you, but we hope you get a lot out of this, and you'll get my contact information and information for others in the department that you can send an email if you have questions that are not answered in this session. So let's get going. So before we get to the main part of the presentation, I do need to take a moment to discuss names. The Department of Multidisciplinary Engineering offers several different degrees, and one of these degrees is the Bachelor of Science, or BS, in Interdisciplinary Engineering. And I know these names are very, very confusing, but the thing to know is that if you are filling out your ETAM application and you want to do what it is we're talking about here, you need to choose Interdisciplinary Engineering. That is actually the one thing that you'll see. You won't see Multidisciplinary Engineering with an M. So look for Interdisciplinary Engineering with an I. Let's move on to more important things like what exactly is multidisciplinary engineering? Well, it's a variety of programs at the undergraduate and graduate levels, and we'll flash a few of the names up here. We'll talk about some of these as we go on along in the presentation, but the basic idea behind every single one of these is that we want to discard the traditional academic boundaries between the departments within the College of Engineering and also between the College of Engineering and other colleges and departments and the university. Another way of saying this is that we want to blow up the academic silos and give you new opportunities that cross those boundaries. Well, what exactly does that mean? Let me give you an example that I think will help a lot. Hopefully you'll one day see driving down the road one of these, and this is not a typical minivan. This is a self-driving car or autonomous vehicle. This particular one is from Waymo, which is part of the Google or Alphabet family of companies. And you'll notice that it's got that big weird hump thing on top. We'll talk about that more in just a second. So what kind of engineer designs and makes autonomous vehicles or self-driving cars? Well, traditionally, cars have been the domain of mechanical engineers. They understand internal combustion engines and braking systems and suspension and transmissions. And in fact, the mechanical engineering department here at A&M has an organization called the Society of Automotive Engineers, which is a fabulous organization that you might be interested in joining. But this vehicle, like we mentioned a second ago, is not typical. It's got that big hump of sensors on the top: LiDAR, ultrasonic, infrared. And sensors are really the domain of electrical engineers. They're the folks who understand how to make these things, how to use them to get useful data. And boy, do they produce data. In fact, they produce truckloads of data, pardon the pun. And who is it that really understands how to take those huge streams of data and turn it into useful insight and information? Well, that's what computer scientists do. They take all that stuff coming from the LiDAR and the ultrasonic sensors, and they turn that into information like there's a vehicle in the lane next to me, or there's a pedestrian crossing the street 30 yards down the road. And of course, speaking of roads, these autonomous vehicles are going to be driving on streets and roads, and those are designed by civil engineers. And everything that we do in designing roads for human drivers is probably going to be different as we see more and more autonomous vehicles on the road. Everything from the color of the paint we use to mark the pavement, to signage, to the curvature, both horizontally and vertically, that the road can have. All of these things are going to be changing as we see more and more self-driving cars. Now, once we get these things refined and we're ready to bring them to market, we want to manufacture these things at large scale. How do we set up efficient manufacturing processes? Well, that's what industrial engineers are really, really good at. And of course, we want to sell thousands or hundreds of thousands of these things and come up with a really viable business model. Well, who understands business? Well, the business people. They can figure out new business models, new ways of owning a car or owning the ability to use a car that might be more applicable in the case of self-driving cars. And speaking of new ways of owning or new problems that are going to come up, there's a whole new set of problems that comes up when you have self-driving cars that we really need to work with the philosophers and ethicists to come up with good answers to questions. For example, if this vehicle is involved in an accident and none of the human drivers are at fault, well, who is at fault when you're talking about a self-driving car? Is it the computer scientist who wrote all the data processing algorithms, or the electrical engineer who designed all the sensors, or is it the civil engineer who designed the roads? These are problems and questions we've never really contemplated before, and we're going to have to find answers that work for society if these self-driving cars are going to be a thing that's going to work. So back to a question we asked a minute ago, what kind of engineer designs and makes self-driving cars? Well, there really isn't a single kind of engineer that does it. You have to know a lot about a lot of different things to be effective at making self-driving cars. And that kind of shows the utility of what we want to do in interdisciplinary engineering. The traditional model of how we educate you to be an engineer is we say, okay, go to the Department of Mechanical Engineering, for example, and take a bunch of courses that they tell you you have to take and make grades of C or better in to call yourself a mechanical engineer. Or go to electrical engineering, and they're going to give you a different set of courses that you're going to have to take and pass to be an electrical engineer. Here we're saying, no, let's not start with a list of courses and a body of knowledge first. Let's start first with the problem. And once we know what the problem is, let's figure out what specific bits of knowledge and skill do I need to solve that problem. So if you want to work on a problem that doesn't really seem to fit within these traditional academic boundaries, interdisciplinary engineering is the place for you, because we will work with you to design an academic program that really is what you need to solve that problem, or to bring that product to market, or to make that contribution to society, to make it a better place to live. And it may very well involve all kinds of things from all sorts of places, including places outside the College of Engineering. So how is it that you go about pursuing the BS in Interdisciplinary Engineering? There's two fundamental pathways that we'll talk about here through the rest of the presentation. Number one is what we call design your own degree, and number two are our predefined tracks. So let's get into those in detail. Here's a couple of examples of past students and what they did with design your own degree. A few years ago, we had one student who took elements of biomedical engineering, and she combined that with mechanical engineering, and she combined that with kinesiology, and she put that together into a program focused on the engineering of orthotics and prosthetics. Another student took elements of aerospace engineering, computer science, and physics, and he put all that together into a degree program focused on high-performance computing for aerodynamics. One thing I do want to point out here with these diagrams is to show you that when we say interdisciplinary engineering, we don't just mean engineering disciplines. Notice that both of these students went outside of the College of Engineering for some of the major components of knowledge that they wanted to bring into their degree programs. Let's look at another case. This is a student who worked on a degree program focused on product development. And to give you more details of what the courses actually look like within one of these degree programs, you'll notice that this particular student took a lot of courses in mechanical engineering, and they went all the way up into the 300 and 400 level of course. We actually require you to do that. And this student took a lot of courses in engineering entrepreneurship, an area that is actually a minor that fits within the Department of Multidisciplinary Engineering. And one more example, this actually returns to a student we looked at a minute ago. This was the student who focused on orthotics and prosthetics. So here are the courses that she took from biomedical engineering in the top box. In the bottom left box, these are the courses she took from mechanical engineering. And then she combined, in addition to the kinesiology I mentioned, she also combined a bunch of courses from psychology. And this makes sense when you're talking about things like orthotics and prosthetics. One of the things that a user of a prosthetic has to do is they have a psychological shift that they have to make in understanding how this new device becomes an extension of their body and how they use it effectively. So let's move on to the second pathway, and this is our predefined tracks or predefined programs you see here. Now that picture that you see right there, that is the College of Engineering Advisory Board. So these are folks who are very senior. These are the CEOs and presidents and VPs of major international companies. And they come twice a year to the Texas A&M campus, and they meet with the dean, and oftentimes they are meeting with the dean to say, hey, there's this new thing that we're doing, and we don't really think that graduates coming out right now are well prepared to do that. And so what happens is that the dean actually comes to our department and says, hey, we are hearing from industry that we need to have degree programs focused on this new thing that they're doing. So we then work with industry to come up with these novel academic programs that are focused on the things that industry is asking for. And that's key because oftentimes people will say, I've never heard of interdisciplinary engineering. Is this something that I can actually get a job with? And we're here to tell you, actually, we're producing the academic programs that industry says that they want. So of course there's going to be jobs, and we'll even connect you with the folks who help us design these programs. So let's look at several examples of these. We've got a lot of them. We have a whole suite of these that are focused on various aspects of manufacturing. So advanced manufacturing, engineering manufacturing operations, hardware systems and controls, and we'll also put in automotive and transportation engineering because those two tracks we offer at the McAllen campus. But this is typically taking elements of mechanical, industrial, electrical, computer science, depending upon how we mix them and match them, we come up with these different tracks, but looking at true 21st century manufacturing. Another predefined track that we offer at the Galveston campus is engineering and marine environments. So this takes elements of ocean engineering, which is about building structures in the offshore environment, like offshore oil platforms, but also looks at the marine hazards, the natural hazards that those structures are exposed to, and helps you to understand how to design those structures better to accommodate those hazards and not be damaged when they occur. Another really cool track that we have is engineering for planetary science and space exploration. So if you want to build the next Mars rover, this is the track for you. It takes elements of, depending upon how you want to mix them and match them, mechanical engineering, electrical engineering, and computer science, but also geosciences. Because what that Mars rover actually does is it goes up to Mars and it does a bunch of geology experiments and it does a bunch of atmospheric experiments. So we have you go over and take courses in meteorology, geology, climatology, etc. So you understand not just how to build the hardware, but what is it that the hardware is actually supposed to do. Another area is safety engineering. And this is something that not a lot of people who are freshmen and sophomores even know is a field, but this is huge in industry. Helping workers to be safe on the job and also helping industry companies not have to deal with very, very costly accidents. We actually have a whole institute on campus devoted to safety engineering, and we work with them on this program. A couple of years ago, we worked with Deloitte, which is a major management and technology consulting firm, international in scope, and we came up with a track, Engineering for Technology and Management Consulting. So if you want to work for Deloitte or Accenture or McKinsey or one of many companies that do that kind of work, this is the track for you. Then we also have several programs that we call our combination programs. And this is where we give you the opportunity to pursue a BS in interdisciplinary engineering and a graduate or professional degree in less time than it would take you to do it in a non-combination fashion. So the first of these is the in-law program, engineering in law. And in this program, you earn a BS in ITDE and a Juris Doctor degree, or the degree you have to be a practicing attorney. Now, normally that is 4 years for the BS degree, 3 years for the Juris Doctor degree, 4 plus 3 is 7. This program, you can actually pursue that in 6 years. You actually shave a whole year off of the process of getting to your law degree. And if you think about, what an attorney makes when they get out of school, that's something on the order of like $150,000 or $200,000 in your pocket that you save by not having to go to school for an extra year and getting out and earning money faster. We actually have 2 tracks under this program, one focused on intellectual property and patents, which is a particular strength of the Texas A&M Law School, and we have another one focused on environment, health, and safety. And we are open to students who want to design their own degree program. They want to do something that doesn't fit into those 2 tracks, and they want to pursue the in-law program. Another combination program is NPH, for Engineering and Public Health. Here you earn the BS in ITDE plus a Master of Public Health degree. Normally that's a 4 plus 2 or 6 year process. Here we shave a whole year off and it's only a 5-year process. So again, saving you a tremendous amount of money, but getting you out to the point where you have an engineering degree and a public health degree. And the real emphasis of this program is on wearable health monitoring devices that typically are used in public health contexts through employer-provided healthcare. So the two tracks we've designed for this are for employer-provided healthcare and wearable electronic health devices in the energy industry. So we see these roughnecks here on a drilling platform. It's very, very physically demanding work and can be prone to long-term health problems and injuries. And also the agriculture industry. Again, an area where workers are exposed to various things that if we don't monitor their health, they can have some long-term health impacts. So up till now, we've been talking about the degree programs that we offer here in MTDE. I do want to take a second to talk about the minors that we offer within the department, because you may very well say, hey, I want to do something else, but you might be interested in one of the minors that we offer. And there's two big ones. The first is the minor in engineering project management, and the second is the minor in engineering entrepreneurship. Any engineering student can add this minor to their academic program. If you want to know more about these, please let us know. We'll be happy to share that information, but very, very popular minors that a lot of students are getting a lot out of. We also are one of the few engineering majors that is offered on all 3 of the A&M campuses governed by College Station, so College Station, Galveston, and McAllen. So if you are at one of these campuses and you want to move to another one, talk to us and let us know, and we can tell you about the opportunities we offer at all 3 campuses. So an obvious question that everybody wants to know is, what is the career outlook for this particular major? So I'm showing you the data here straight from the Career Center surveys of our graduates on the day of graduation as they're just about to walk across the stage. And these are all of the companies that are hiring our interdisciplinary engineering graduates. I won't read the list to you. You guys can read, and if you want to see this later, we'll be happy to put it back up on the screen. And we also have a lot of our graduates headed to graduate school programs, medical school programs, law school, not within our in-law program. So there's really no limitations on all the opportunities that are available to you with this degree. And of course, how much money do you make? We can say that, well, we're doing pretty good. Over the past several years, our average starting salary for the BS ITDE graduates has consistently been the highest average starting salary in the College of Engineering. Here, again, it's data straight from the surveys. For spring and fall of 2022, the average was $122,000. You see the range there. That came down just slightly in the spring of 2023. Fall of 2023, that's a skewed sample. We didn't have as many folks there, but you still see it's a very healthy average and range of starting salaries. So this is not a degree where you have to worry about getting a job, nor do you have to worry about getting paid well. So you're going to hear from some of our wonderful students here in just a minute, but I do want to point out some folks that you might want to contact with more questions. Probably the person on the far right is the best point of contact for you right now. That's Mr. Doug Beck. He is our Assistant Director for MTDE programs. You see his email address there. He fields a lot of questions from prospective students, and if there's something that he can't handle, he'll send it either to me, I'm right there in the middle, or to our department head, Dr. Tim Jacobs. So this reaches the end of this video presentation. We're going to turn it over to the great folks who are there in the room with you in person, and they're going to tell you about their experiences in interdisciplinary engineering and answer any questions that you have. Thanks for being here. Hope you've gotten a lot out of this, and gig 'em.